This short tutorial will discuss how to do comparisons when you have two data sets that were chosen from subjects that are completely unique from each other and also meet certain criteria we will call parametric. This statistical test is known as the independent t-test. The question of whether your inferential statistical test should be done with parametric or non-parametric methods is the first thing you need to ask yourself when deciding which would be the best test to use. When done correctly, parametric tests are considered stronger in making conclusions about your data sets. When we are doing a two-group comparison, it's important to consider these two groups as having been manipulated in some manner, presumably defined as the independent variable, such that the dependent variable or the outcome measure will be subsequently affected. And whether these two data sets being compared can be done by parametric methods or not really depends upon if it meets the three main criteria for parametric testing. One of them is easy to determine, and that is whether the data that you are using, which is the dependent variable outcome measure, is measured on a ratio or interval scale. Ratio or interval scale data are simply those measurements which fall along a continuous scale. Ratio has a true zero, whereas interval does not. More information can be noted in Portney and Watkins. Another criteria for parametric testing states that data from each of the two groups need to have a normal, also known as bell-shaped curve, distribution. Fortunately for us, SPSS easily allows us to test this characteristic quite easily. One thing to remember, though, is if you have a group that has a sample data set that has less than 50 cases, you would need to use the Shapiro-Wilks test for normality for that group. If, on the other hand, you have a group that has a sample data set that has more than 50 cases, you would need to consider the Kolmogorov-Smirnov test for normality. SPSS generates both tests at the same time for any given sample data set you are testing, so you just need to look at the correct spot on the SPSS output table to get your answer. What does that mean? If you follow the instructions given on the link provided in the previous slide, you will generate an SPSS output table that looks similar to the one shown here. On the bottom table, you will see the test statistic for the Kolmogorov-Smirnov test as 0.118. This was used with the assumption that you had a fairly large sample size. In contrast, the Shapiro-Wilks test statistic was calculated as 0.965 and was found using a formula which made corrections to allow for smaller samples. The last criteria for parametric testing is whether the variances for each of the two groups are equitable or not significantly different from each other. To do this, SPSS will generate the Levene's test for homogeneity of variance at the same time the t-test output table is generated. The nice thing is that this criteria has a cheat attached to it. That is, even if the variances or standard deviations are not similar to each other, there is a statistical correction that allows you to still use the independent t-test. To distinguish between those two types of t-tests, we refer to them as either an independent t-test with equal variances. This is for when the standard deviations of the two groups are not statistically different from each other, and the independent t-test with unequal variances for when the variances are statistically significant from each other. If we look at this SPSS output, which compared the home scores of the New England Patriots football team to those of the Atlanta Falcons, we can see that Levene's test indicates that there is a p-value of 0.711 when comparing the variances between the two sample data sets, and so they are not significantly different from each other. This means that the independent t-test formula used can be the one used regularly, and the p-value for that comparison is therefore p is equal to 0.127. If, on the other hand, Levine's test had shown a statistically significant difference between the variance of these two groups, meaning if the p-value was less than 0.05, assuming a 95% probability, then we would have looked at the t-statistic in the second row, where the p-value cited is 0.131. The last 3 slides show how you should set up the spreadsheet in the Data View portion of SPSS, as well as what buttons you need to push to generate the SPSS output table shown in the previous slide. For more information, please go to the Portney & Watkins textbook or the layered link provided elsewhere in this course.